It's review time. It's review time. And there's only 3 exams. 3? How are we going to do anything with 3 exams? So, what Miss Newman and I did, mostly Miss Newman did, was we went through a lot of old Regents exams, found a lot of questions that pertain to the current curriculum, and then added in all of the new stuff that the algebra, and we created 5 new Algebra 2 Common Core tests. This will be number 1. Now, if you have not practiced this on your own, do it. If you want a copy of it, it's very simple. Get a copy of it to go to nkinfinity.com. There's the website right there, nkinfinity.com. Go under New York State Algebra Teachers, and right here underneath Review, go to Review. Don't go to Regents. This is where all the Regents exams are. The 3 whopping exams we've had. That's not enough review. We need more. So we go to Review. And in here, you'll see the 5 practice exams we've created. They're all uploaded right now with the answer keys. Now, the work is not there, and if you don't know how to do the problems, that's what you're here for. But try the practice test. Click on the blank, print it out, try it on your own, click on the answer key, see how you did. If you didn't do that well, go back and see what you did wrong, or come to this video. Now, the other thing is here, there are currently 28 documents here, all of the spiral reviews that are all Algebra 2 Common Core type questions as well. I've got 4 of those videos done. I'm hoping to get to the other ones whenever I get free time, but that doesn't happen very often. But anyway, let's get started. We got lots to do. Let's go back. Let's get going. So, what do we got? Question number 1. When x is 0, x is greater than 0. This doesn't mean greater than 0. That doesn't mean greater than 0. That simply means that x is positive. Okay, x is positive. Oh, and a is positive. So x is positive and a is positive. Well, the only way, let's take a look at this thing, 5x to the a over 3. The only way we'll turn into a fraction like this is if we have a negative exponent. We'll never make it into a fraction without a negative exponent. Okay, so those two have to go. Now, here's the issue with this question. What you need to remember about this question is in the denominator is the root, whether it be a cube root, a square root, a fourth root, a fifth root. It is a root. So in this case, if you ignored the fact that there's an a there and you just had a 1/3 here, a 1/3 there, you'd have a cube root. Well, it is a cube root of 5x to the a. Now, I'm not sure if that's how they have it written there. It's not. They have it written like this. The cube root of 5x and that whole thing written to the a. The key is roots are in the ground, right? If you're planting a root, if you're planting a root. Who plants roots? If you're planting a plant, the roots are in the ground. Power up. Oh, power up. Roots are in the ground. Power up. Okay, so this is my power or my exponent. That's what you want to remember about that. So there's the answer. Now, how could I cheat? Well, you simply could cheat by just saying, okay, let's do 5.1 control var. Oh, got to go into calculator mode. 5.1, stow it into x. And then 2.3 control var a. Enter. Sometimes it doesn't like when I press right there. And then just type this in, 5x to the a over 3, parenthesis, 5x raised to the a divided by 3. Hit enter. There it is. Looks exactly like I typed it in. And then we're going to do the cube root of 5x. Oops. I forgot that whole thing had to be in parentheses. Raised to the a. Oh, look at that. They're the same. Now, you should know how to do these problems, but that's a nice way to cheat. Coffee time! One problem in and I'm already drinking coffee. All right, here we go. Mike averaged 90. Woo-hoo! Mike, nice job on the first 3 tests in physics. So he got a 90, he got a 90, and he got a 90. Did he really get a 90, 90, 90? No. He could have gotten an 89, 89, and a 92. I don't know, but why make yourself difficult? There's an average of 90 tests, 90 points on 3 tests. If he scores a 98 on each of the remaining tests, his average will be 95. Which equation would be used to represent or determine how many exams there are? Well, currently, I'm going to divide by 3, right? That would be his average. There it is. And that's 270 divided by 3, which would give me an average of, oh, lo and behold, 90. Now I'm going to add a 98. So we're going to add a 98 and add a 98. Holy crappy math. Let's get neat. Let's get neat. I'm being sloppy. Plus. We're going to add a 98. We're going to add a 98. And then we're going to add, I don't even know how many 98s to add. I'm just going to keep on adding. Keep on adding. Keep on adding. Okay, but I don't know how many to add. So let's add E. E of these. Well, if I add E of those, if E was 3, then I would do 98 times 3. If E was 4, I'd do 98 times 4. In this case, I have no idea what E is, so I'm going to do 98 times E. Now, there were 3 exams. We divided by 3, but now I got a crap load more exams. How many more? E more. So I'm going to divide by 3 plus E. And hopefully that's an answer. And I want my average to end up being a 95. So these don't make any sense. I want my average to be a 95. There it is right there. Ka-ching, the winner. Winner, winner, chicken dinner. All right, this is the imaginary I. This is not an I variable. So you have to remember that. It's not like, oh, look, we have an I. So this is 3 minus xi squared, which really just means we're going to multiply it by itself. So 3 times 3 is 9. How many have 9? Oh, they all have 9. 3 times this is negative 3i, and that's also negative 3i. That makes 6xi. Negative 3xi and negative 3xi make negative 6xi. Oh, that was a great one. I love that joke. Not really. I'm just kidding. And then we're going to multiply these suckers together. Now, this is where it gets a little bit funky. X times that, well, first of all, it's positive because it's negative times negative. X times x is x squared. And I times I is I squared. And my friends, this is where we got to get a little crazy. That is the problem right there. You have to remember that I squared is really a negative 1. Multiplying by I squared just changes your sign because you're multiplying by negative. So if you're already negative, you become positive. If you're positive, you become negative. So the answer to this question is 9 minus 6xi. Nothing to do with just a plain old I. It's just when you have higher roots of that. Minus x squared. Ka-ching, the big winner. All right, let's go on. All right, so let's see. This is an incredibly easy question. It has 2 real zeros, which means it hits the axis twice. Hits the axis 3 times, hits the axis twice, hits the axis 3 times, hits the axis 4 times. Here's the right answer. Just based on that. So this isn't my favorite question. We probably will change this, throw this one out. It's not a great question, but let's talk about what this means, because you really should know what this means. This is the end behavior of a graph. And what we mean by end behavior of a graph is simply what's going on in where the arrows are, the tails are. So what this states is as x goes to positive infinity, as x is going to the right, y is going to not right or left, but up, and that's this one as well. So either way, that's a that's a gimme question. Hopefully you get one that easy on the test and you just bang through it. All right, so this question, quite frankly, if you wanted to, you can just check your answers and see which ones work. However, I would like to just do this the mathematical way. The mathematical way is to say, okay, we're going to get this weird thing alone, so we're going to move this x over and make it negative x minus or plus 5. See, all I did was move this x over. And then to get rid of the squared term or the square root term, I squared both sides. So I get x plus 1 equals, that's negative x times negative x, that's positive x squared, minus 5x plus 25. Now, I don't know about your teacher, but I expect my kids to show work. Now, I don't mind Regents time, you stowing answers and checking them. You know, come over here and check these answers. In fact, I'm going to show you how to do that in just a second. But when I'm practicing for the Regents, don't get lazy and just use the cheats all the time. It's not going to work all the time. Practice. Subtract the 1, subtract the 1. This is a quadratic. It has to be set equal to 0. X squared minus, this gives me minus 11x plus 24. That's a 24, by the way. It looks like a 5, but it's really a 4. Oh, the comedy is just amazing. We're going to factor this sucker. Factoring's pretty easy. Multiply to 24, add up to negative 11. That's minus 3 and minus 8. Should have known that those were going to be the numbers because, well, there's only 3's and 8's over here. So my two answers appear to be x equals 3 and x equals 8. Now, every time you solve a radical equation, you must check your answers for extraneous solutions. So what I would have done with my calculator anyway, just to cheat, I'm going to do right now. So I'm going to take 3, I'm going to store it into x, and I'm going to type the original problem. The original problem was x plus the square root of x plus 1. Of course, we might want to put the x in. Whatever. Get off my screen. X. And I got 5. Well, I wanted it to be 5. So that's good. That one worked. That one worked beautifully. Okay, so now let's check the other one. 8, control var x, and press enter. And hit the up arrow. And press enter. And I get 11. Oh. But I wanted it to be 5. I don't want it to be 11. I want it to be 5. So 8 is an extraneous solution. So the only answer is this one. Now, I could have just stowed the answers in and just checked to see which ones work. But I want you to be able to do that work. All right, so find the zeros of this function. Zeros. Zeros. Again, I could just take these answers, stow them in, and see which one works. But what's the fun in that? We need to do some mathematics. So we're going to set this thing equal to 0, which we already did. And we're going to factor it by grouping. So these two, group, oh, that's root, I don't know. Guardians of the Galaxy are coming out soon. What does the guy say? Groot. Take out an x squared. And I'm left with x plus 2. Minus, now what can I take out of these? 25. But I'm really taking out a negative 25. So I'm left with x plus 2. Notice that these two sets of parentheses match. That's my first set of parentheses, x plus 2. My second set are whatever is left over when I take those away. And that would be x squared minus 25. Now I hope you recognize that to be the difference of two squares. I hope so. So this is just x plus 2, and this is x plus 5, x minus 5 equals 0. So my three answers are x equals negative 2, x equals negative 5, and x equals positive 5. So negative 2, not negative 1, negative 2 plus and minus 5. There it is, the big winner. Winner, winner, chicken. Whatever. Okay, apparently we got some red chips. And we simulated drawings of size 30 from a population. So I don't know how many times, I don't know how many dots there are. It looks like there's about 50 dots. So maybe n was equal to 50. That's the number of simulations we ran. And we took our sample size was Well, maybe our sample size was size 30, whatever. Our sample size is size 30, and we did this 50 times. So we ran a simple random sample, or simulated simple random sample of size 30, okay? And so when I'm looking at this, what I'm looking at here, it says what is most likely to come from this population. So I'm looking at this simple random sample, and it appears to be normally distributed, or relatively normally distributed. Looks maybe a little bit higher on this end than on this end. So somewhere at this peak would certainly be the average. And since it's a little heavier over here, I'm thinking maybe 12 might be the peak. Could be 13. Could be 13. 12 would be the peak. So I'm looking at a random sample of 12, and most likely to come from this population is 12 random chips from a sample size of 30. There it is. Straightforward. Nothing difficult about that problem, kids. All right, what do we got here? If f of x equals that and g of x equals that, which of these is false? So we got to add them, subtract them, multiply them, and then divide them. That's a pain. Well, adding them's pretty easy. If you just add these two, so let me put them over here. X squared minus 4 plus 2x plus 4. If I added those, these 4's just cancel, and I end up with x squared plus 2x. So that one's not right. Now that one is right, so it's not right, because I was looking for false. Remember, New York State loves to write the word not, or false, or which one's not going to happen, or, you know, they used to those negatives in there. So grab a highlighter, highlight them, go, oh, can't trick me. Okay, you talk like that, you're not going to have a lot of friends, I'm just going to say. I know from kind of experience. Me and my coffee cup, we're friends. So let's subtract them. Now, the subtracting part's a little bit tricky here, kids. And be on the lookout for subtraction. The hardest thing you're going to do on an Algebra 2 test in some instances, is subtract. I'm not going to lie. Because if you just write this down, x squared minus 4 minus 2x plus 4, you will think, oh, look, it's x squared minus 2x. Oh, look, that's not right. What a joke. That actually turns out to be the right answer. But really what you should be doing here is, you should be distributing this negative. And you get x squared minus 4 minus 2x minus 4. And so what ends up with x squared minus 2x minus 8. And this has a plus 8. So this is the right answer. If you multiply them, you get that mess. And if you divide them, I guess you get that. Let me show the division. And the multiplication I'm just going to avoid for now. Yeah. What am I doing? Oh, I'm going to divide them. So I'm going to take x squared minus 4, which is really x plus 2, x minus 2. That's this. Divided by, and then this one I can take out a 2. So 2, x plus 2. And the x plus 2's cancel, and I end up with that. All right, let's move. On a New York State Math 8 exam, the mean is 73 and the standard deviation is 7. If the normally distributed, what approximate, okay, 66, so let's draw our normal distribution curve. You guys should be getting pretty good at these by now. Drawing these enough times. 73, we're going to go down to 66, and we're going to go up to 80. Now, let's just say you don't have a clue what the answer is. Let's say you don't have a clue, but you can use your calculator. By the way, we just went down 1 standard deviation and 1 up 1 standard deviation, and you should know by now that up and down 1 standard deviation is 68%. But if you want to learn how to use your calculator, stick around for a little bit bigger example. Let me show how to use the calculator. Now, this calculator is not going to come out with exactly 68, but it's going to come out with something so close that you would have to pick that. So let's go to the calculator, and I'm going to tell you right now, the keystrokes are simply menu 552, but menu 5 probability, 5 distributions, and normal CDF, cumulative density frequency, right there. What's my lower bound? My lower bound is 66. What's my upper bound? My upper bound was 80. Did I not write that on there? Oh, 80. 80. My mean was 73, and my standard deviation was 7. And I click OK, and it gives me 68.2. Now, that 68.2 should ring a bell to you all, because up and down one standard deviation is 68.2. That's why it says approximately, not exactly. The high school, Hilton High School, we always use Hilton. Sorry, other schools. We like Hilton. Has an audition, has 32 seats in the first row, and each seat has 4 more seats than the row before it. Which expression represents the number of seats in the nth row? Well, if you don't know that this is an arithmetic sequence, then you are not doing well. We'll talk about that in a second. Okay, sorry, I want to make sure I got the formula sheet. Now, an arithmetic sequence. How do you know it's an arithmetic sequence? Because we're adding 4, adding 4, adding 4. I'm not multiplying. It's not expanding my multiplication. That's a geometric sequence. We're adding. And so the arithmetic sequence formula is on your formula sheet. It's right, where'd my pen go? It's right here. So there's your arithmetic sequence formula. You should know it. Probably have it memorized by now anyway. So let's go back to my test. So it's a sub n is equal to a sub 1 plus n minus 1 times d. Now d stands for your common difference. This is a sub 1, that's your first term. And n is just the number of rows. So in this case, all I got to do is say a sub n is equal to, well, there's 32 seats in my first row. So I'm going to go 32 plus n minus 1 times my common difference. Well, how many more in each row? 4. There it is, 4. Now, if I plug in 1 in here, you'll notice that this all goes away because it's 0, and I end up with 32. If I plug in 2 in here, you'll see that that's 36, and that would give me row 2. So there it is, and the answer is choice 4. Yes. Oh, my poor Buffalo Bills. I'm a huge Buffalo Bills fan. Huge. I've been a huge Buffalo Bills fan since whatever. I hope McDermott turns things around. Come on, McDermott, turn things around. Anyway, they win 65% of their games. So the probability of win equals 0.65. There's a 30% chance of snow on Sunday. The probability of snow equals 0.30. If the probability that it snows given the Bills win, so the probability of snow given the Bills win is equal to 0.3. Now, there are 3 tests. So complements, so the 2 events are complements. Complements mean probability of snow, probability of not snow. They would have to add up to 1. Now, these closely add up to 1, but not 1. So, no. Mutually exclusive means the probability of win and the probability of snow is equal to 0. Well, I'm not actually sure what the probability of win times the I don't know what it is, so I'm going to guess it's not this one. So it's either independent or dependent. There are 3 tests for independence. Really, there's just one. There's 2. So it's the probability of A given B is equal to the probability of A. The probability of B given A is equal to the probability of B. So it doesn't matter as long as, so basically what we're saying for those of you that haven't learned this is, it doesn't matter that this happened. If this wasn't here, I would have probability of A equals probability of A. But it is there, so, or in this case, the probability of A equals the probability of A, or the probability of B equals the probability of B. It doesn't matter that A happened. In this case, it didn't matter that B happened. So in this particular case, what we need to show or prove for independence is, does the probability of snow equal the probability of snow given that they win? Because remember, if we don't care about if they win, is this going to be the same here? And yes, it is. 0.3 equals 0.3. They are, in fact, independent events. And that's the test for probability. All right, so the roots, we got to factor. Now notice these things. We're not factoring, kids. Not going to happen. I'm going to show you how to cheat on this problem. Stay with me. I'm going to show you how to do the real math first, though. So I'm going to do this by completing the square. You could do this by quadratic formula. So I'm going to do it all 3 ways because this is a lot of fun. So we're going to do it by completing the square first, get the right answer. Then we're going to do it by quadratic formula, get the right answer. And then we're going to cheat. I'm not really cheating. I'll just use my calculator to help me. Whatever. So the rules of completing the square state, make sure your leading coefficient is 1. That's done. Tag that negative, bring that 9 over and I say to my kids, put a box here. That's why I call it completing the square, because I put a square there. That's not really why it's called completing the square. So on the next step, we need to decide what goes in that square. Well, it's going to be x minus whatever half of this is. Half of that is 2. It's actually negative 2. If I square negative 2, I get 4. So because I have 4 there, I got to add a box over here with a 4 in it. This gives me negative 5. Okay, negative 5. Now I'm going to take the square root of both sides, and I get x minus 2 equals plus or minus the square root of negative 5. Well, the square root of a negative is just I. So what I end up with is x equals, when I bring this 2 over and put it right there in front, 2 plus or minus I square roots of 5. There it is. So I think this is my right answer. Now let's try it using the quadratic formula. A equals 1, B equals negative 4, C equals 9. I always do D, which stands for discriminant, B squared minus 4AC. Remember, the quadratic formula is on your formula sheet. It's right there. Okay, and there's the B squared minus 4AC right there. And that's the piece I'm going to do right now. So x equals negative b is 4 over 2 times 1. I always split these up. Plus or minus the square root. Oh, I didn't do the discriminant. So the discriminant, b squared is 16 minus 4 times 1 times 9. That's negative 20. All over 2 times 1. So I got to not only take out this I here, but I got to simplify the square root of 20, which is the square root of 4 times 5, which is really 2 square roots of 5. So this becomes 2 square roots of 5. So I get x equals 4 divided by 2 is 2 plus or minus I. Now notice these 2's cancel here, right? Square roots of 5. So I get the same answer that way. Now you're probably like, okay, Krause, you promised. Tell us how to cheat. Okay, let's do that then. Let's not call it cheating, though. Let's call it productive use of our graphing calculator. So we're going to do 2 plus I is in here times the square root of 5. And I'm going to stow that into x. Boom, there it is. And then I'm going to type in my original answer. X squared minus 4x plus 9. And I hope to get 0. 0. There it is. Done. Now I can do the negative as well. Ding, 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 ding. Enter. I don't want to retype that. Just put minus in. Hit enter. Go up here. I better get 0 with this one as well. There it is. 0. There's the answer. Now why? What does that work? Well, let's try. Let's try. Let's see if we thought it was 2. Let's see if we thought it was 2. We said this was, oh yeah, it should be, I think I got 2, 13. And I type this in, and you get negative 8. It's not 0. I want 0. I need 0. So that's a way to use your calculator to see if you get the right answers. Now again, if this is a part 2 question, guys, you got to be able to do it the right way. If it's a part 1 question, use the answers to help you. Hit subscribe, hit like. The next part's coming in a few minutes after I have my breakfast and some more coffee. Bye, kids.